welcome. We had a bit of a hiatus under the summer, as we do. And this is the 14th meetup of the Feature Store Global Meetup Group. So welcome everyone who's joining. It's organized by HOPSWORKS. My name is Jim Dowling. And today we're delighted to have Fabio Busso, who's the VP of Engineering at HOPSWORKS, talk about version 3 of HOPSWORKS and its Python-centric approach to feature stores. Before we get started, I'd like to announce that there is, we have of course a Slack channel, but we have a conference coming up on October the 11th. So featurestoresummit.org if you want to register, and you can see we have a really exciting lineup of speakers. So we have people like Uber, LinkedIn, DoorDash, Disney, lots of great other, we've got an author from Manning who wrote a book on feature engineering. So some really great speakers, and it's a free event. It's an online event, and we'd love for people to participate and be active as well on the Slack. So without any further ado, I'm going to hand over to Fabio, and he's going to talk about a Python-centric feature store, HOPSWORKS. So I'm going to stop sharing my screen, Fabio.
Yeah, let me go ahead and share mine.
I would remind people that just for questions, there's a Q&A button in the bottom in Zoom, and there's also a chat button. It's better if you ask the questions in Q&A, because then we can click them off as answered rather than in the chat, because sometimes when you get chat, it just sends to the panelists. Just use the Q&A button if you can. Thank you. Fabio.
Thank you, Jim. Thank you, everybody, for joining. So as the title says, today we're going to be looking at the new release of HOPSWORKS that we did over the summer. And with the new release of HOPSWORKS 3.0, we're also going to be looking at the new approach that HOPSWORKS takes and like how it enables Python and data scientists to kind of use the feature store in a more user-friendly and developer-friendly way, essentially, right? So I know this is a feature store meetup, but like if you joined for the first time and you're just curious about it, like why HOPSWORKS, we think that like feature store are a key component for like operational ML. This kind of slides kind of like summarize that. So like we divide from a conceptual point of view, we divide machine learning into two different areas, right? We do like what we call laptop ML, essentially like building up models, pulling data on your laptop, building up your model, and that's pretty much it, right? So what we see the value of the feature store is started to kind of put in this model in production, whether it's what we call analytical models, so essentially for instance stuff like batch processing. So every day you get a bunch of new data to score, and you move on all the way to real-time operational ML of the like of I don't know, TikTok, or even some of our customers looking at anomaly detection and so on and so forth. So you have a stream of events coming in, you're processing them, and you're making requests in real time. So all these need context. So all these both analytics and operational ML need obviously context to be able to make predictions, and that context comes from the feature store, right? So again, at the high level, the feature store doesn't bring itself any data, but it enables users and data scientists to kind of like use it and leverage the data that the company might already have, right? So from I don't know, data warehouses, data lakes, streams, system of records, and so on and so forth, and be able to kind of make that data available for both model training, but also for what we call prediction services. So essentially either real-time applications or batch to be able to kind of score data and make predictions, essentially, right? So that's kind of like the feature store and the HOPSWORKS feature store at eye level. If we drill down, and this is we started introducing some of the components that we added, some of the entities that we added in HOPSWORKS 3.0 to make the platform more like Python-centric, essentially, right? So at eye level, right, like the HOPSWORKS Feature Store has two APIs, right? So there is a one API for writing, and there is one API for reading, right? So connecting from a writing perspective, like, it's all the processes. The process is all about taking data from the enterprise sources, like can be Snowflake, can be data warehouses, can be a data lake, and so on, and do feature engineering on top of it, and essentially write that to the feature store, right? Register those features to the feature store, and the tool we use and the process we use in HOPSWORKS for that is essentially the feature groups, right? So that's something already always existed in HOPSWORKS throughout all the versions, and we see later in the presentation how we made the process more Python friendly, essentially, right? So that's one aspect. What is new in HOPSWORKS 3.0 is actually the other component, is the feature views, right? So we're going to be digging a little bit deeper later on in the presentation, but essentially from a high-level perspective, you can see the feature view as the gateway for which you access the features in the feature store. So the feature view contains a set of metadata, and we're going to be digging a little bit later into what those metadata are, and that allows you basically to select features and read those features and use those features for building applications and building models and deploying models, essentially, right? So we drop a set of functionalities that we can look into. I have a quick demo afterwards. We're going to be looking at stuff like how do we do search. We provide every component is version, so you can handle multiple versions at the same time. You can make changes without breaking existing pipelines and so on and so forth. We're looking at statistics, we're looking at code, and so on and so forth. So all these aspects are baked into the platform, and they're provided as services to the feature store, essentially, right? So, and as a global platform, like as a full platform, right? The core values again is also to create features, to serve those features, to monitor those features, and to share those features, and so on. So the HOPSWORKS version 3.0 is, as mentioned, the latest release of HOPSWORKS, and the focus that this release has is being Python-centric. And what that means is that we put like particular focus on making sure that the Python experience is perfect, right? So it's making sure that like data scientists really feel at home when using HOPSWORKS, both to create features, but also to use those features to create models and so on and so forth, right? So why did we do that? So there's a tweet from Sarah Catanzaro, who's a VC in the Valley. She should be thinking about this problem as well, and the broader community has been thinking about this problem as well. It's like the SQL versus Python conversation, right? From our perspective, and I agree with Sarah here, it's essentially, it's not that SQL is the wrong tool, but there are a lot of cases where SQL is not enough, right? So there are a lot of cases, and we're going to make a bunch of examples in a second, where there are better tools that can help, and the better tools that achieve results, and that tool is essentially Python, right? So in details, right? So if you look again at the entire ecosystem, and we focus on the feature group side of things, right? So how do we do feature engineering? How do we write features? And how do we do that in a Python-centric manner, right? So from that perspective, right, like what we see in terms of a feature engineering pipeline is obviously there are different components that make the feature engineering pipeline. There are different use cases, and there are different approaches that you can take, right? So one key thing that we do in HOPSWORKS as a feature store is actually we differentiate between what is a feature pipeline and what has actually transformations, right? So, and on one side you have things like aggregations, like you take the number of clicks the user has done in any given time in the past 5 minutes or something like that, right? And that's an example of aggregation. And you can achieve that in several different ways. You can do that in SQL, for instance, if you have a data warehouse like a Lambda SQL query. You can build it in Python. You can build it in Pandas. You can also build it in Spark if you're a Spark user. You can do it in PySpark or even Scala Spark and so on, right? So those are like, you know, obviously the general aspects that most of the use cases actually that deal with that. There are different set of use cases. That's usually NLP use cases where you're dealing with dimensionality reduction, right? So think about you have some text and you want to compute embeddings out of those texts, right? So there are obviously libraries. Probably the most popular one is from Hugging Face. Allows you to basically just provide the text. They have pre-trained encoders that you can just import and basically you just get your embeddings out. And that's mostly done in Python. I don't know any way you can do that in SQL, to be honest. So just it's done in Python. Always part of the feature pipeline, we actually consider also validation, right? So one of the things that, and I'm going to touch upon later, one of the things we did in HOPSWORKS 3.0 is actually to integrate a great expectation. So the core idea is that the feature store is a place where data scientists can actually go and pick up data to train the model. And from a feature store perspective, you want to make sure that the data is actually of high quality, right? So you don't want to make sure you don't want to end up with like bad data into the feature store, because then someone who doesn't maybe know how the feature is computed or doesn't really care, just going to use that, and that's something broken, right? So you want to make sure that you have validation in place to actually build a really quality features and feature store essentially. And again, like the most popular library that we have, I mean, there are different tools that are there, but probably the most popular library out there at this moment is Great Expectation, and that's also done in Python, right? So those are like two things that you pretty much achieve in Python. On the other side of the feature store, right, it's always part of the pipeline, right? But like once you have the data, once you have the features registered in the feature store, and you want to use those features, you might want to apply things like normalization. You want to apply things like one-hot encoding or things like that, right? So the basic idea is that, and we can discuss a little bit later, or like if people are curious, we can just have it in the Q&A later on. The basic idea is that to be able to increment utilization of features in the feature store, you don't want to apply these things at the beginning, like when you're ingesting. You want to apply them later, and we see an example later on why this is important. But all this tool, like there's like things like scikit-learn, even PyTorch and so on. They do have like a lot of built-in libraries that are useful for doing this kind of normalization and one-hot encoding and so on and so forth. So from a data science perspective, a lot of this actually happen already in Python. So that's one other point of like why do we need to be why a feature store needs to be Python-centric essentially. But like at HOPSWORKS, we've been working with customer and user for a while now. The pattern we have seen is that even for, like, if you look at specifically for aggregations, the pattern we have seen is that, especially when you give the feature store in the hands of data scientists, is that they prefer to do everything in Python, right? And like, doesn't matter if you can achieve that in SQL, doesn't matter if you can achieve that in Spark and so on. What they want to do is basically they want to make sure everything is done. They want to do everything in Python because that's what they're familiar with. And from our perspective of people that build HOPSWORKS, obviously we want to make sure that the experience they have a good experience as well, right? So that's the kind of the motivation for which we actually spend time in HOPSWORKS 3.0 to build a Python-centered feature store. So what does that mean in practice, right? So these are taken, we have published some tutorials. You can see the link down here at the bottom. We have published some tutorials that you can run, and I show you in a second that I have a quick demo on how to run them and where to run them. But essentially, from a feature engineering perspective, again, if we go through the different example, this is like a quick example for aggregations, right? So we are basically computing the mean. I think the mean is let me double check. Yeah, computing the mean of a set of features, of a set of values, and we're doing that in pandas. And then what we basically end up doing, if you look at like between line 10 and 16, is basically registering this pandas data frame as features in HOPSWORKS, right? So you don't have to rework kind of your workflow and so on. You just like you keep like building features. You keep your feature engineering pipeline in pandas. And instead of just like save them on a CSV file on a random S3 bucket, you can basically call the feature store API and say, okay, feature store, please register these features with HOPSWORKS, and then from there on you have access to the UI, you have access to search capabilities, you have access to lineage capability, and so on and so forth. So you have access to all the features that the feature store provide, as well as making your pandas data frame available for your colleagues and the rest of the team to be able to kind of use that essentially, right? So that's pretty much like from a feature engineering perspective, that's pretty much what you have to do. Like you have to add this 9 lines of code plus comments and empty spaces. So like let's say 6 lines of code to be able to actually register the features to the feature store and the pandas data frame to the feature store. And there is a bunch of different like parameters you can specify. In particular, in a second, we're going to be looking at the event time and why the event time is useful. This is another example. We're talking about dimensionality reduction. So we're looking at computing embeddings from using the Eigenface library. It's similar in concept, right? So you basically do that in a pandas data frame, and then you take the pandas data frame. You say, okay, register. These are my book title embeddings. I'm going to register those with the feature store and make those available for people to use and share and so on and so forth, right? So again, same configuration, same parameters, and same concept at the end. So I was mentioning that's something that we did. We built in Python, in HOPSWORKS 3.0. So one of the core concepts of the feature store is making sure that the data that lands in the feature store is of high quality, right? Making sure that like people can go off and build model with the data available in the feature store without really thinking, can I read trust this source, or can I really what are the behaviors of this? Can I make some assumptions, right? So those assumptions are encoded as a rule in the feature group itself through the support that we added in HOPSWORKS 3.0 with Great Expectations, right? So you can say things like, and I think I have an example here. Yes. You can say, for instance, like, we have transaction data and we want to make sure that the credit card expiration is not negative, right? So the data, the operation has been done on a credit card that has not expired, right? So that's an assumption people might want to make, right? So you can write a rule in Great Expectation, and you can attach that as part of the feature store, right? So again, it's Python native. The entire library, you can use the entire library in the entire Great Expectation library, and then basically what you have to provide to HOPSWORKS is basically say, you see like line 24, you can basically say, hey, this is my Great Expectation suite, which is the way Great Expectation collect a set of different rules and properties that you want your data to have, and basically register that with the feature store. And then what the feature store provides you essentially is two things. So the one thing is provides you that every time you call insert, so line 28 in this example, every time you add data, you basically are gonna, like, feature store is gonna make sure that the data that you provide is actually respects the rules that you have defined. So that's one thing. The other thing that the feature store provides is basically it provides you a way to actually see the report. So you can see how data has landed, if the data was rejected, why it was rejected, and so on and so forth, and as well as getting alerts, right? So you can configure HOPSWORKS to say, okay, every time some data is rejected because the assumptions are not correct anymore, then send me an alert by email or send me an alert. This is an example, send me an alert on Slack or something. So you take your pandas data frame, data validation is run. So the grid expectation suite is run. And then if the data is correct, then the data lands in the feature group. If data is not correct, then an alert is popped up and someone can have a look at the pipeline, making sure that, make sure the pipeline is up to date, or making sure that there is no upstream issue that need to be addressed, essentially. So that's the level of integration that we have in HOPSWORKS with grid expectation. And again, you can take your, if you already have an existing pipeline and you're already using grid expectation, you can pretty much dump the entire expectation suite to HOPSWORKS, and HOPSWORKS is going to just use that one to run, essentially. So you don't have to recreate the expectation suite just because you wanna start using HOPSWORKS. And there is a final point that's not really Python-centric, but if you have looked at HOPSWORKS earlier, like in previous releases, you saw this is a different way we have to handle data that we provide to users to handle data. Right, that's more an enterprise-y kind of thing, where essentially you have data on Snowflake. You might already have existing features, existing pipeline running, and outputting data in Snowflake or Redshift and so on and so forth. From like an enterprise point of view, you don't want to necessarily have to rework that pipelines just because you want to adopt HOPSWORKS. You can basically instruct HOPSWORKS to say, okay, here's a feature group. By the way, the data of this feature group is in this Snowflake table or is in this Redshift table, and so on and so forth. So we provide connectors to be able to link the feature store to different data sources, and then be able to kind of register the metadata for those features and those feature groups and so on with the external data that is available outside, right? And then you can also do interesting thing. You can use those features to be able to build the live features. So you can basically again pull up your pandas data frame and be able to kind of augment your features, add additional features and register that as the live features feature store. You can register like grid expectation suite again with an external feature group. So you have data on Snowflake. You register that data as a feature group in HOPSWORKS. You attach the expectation suite to the feature group, and then you can basically say that that data gets validated, and you can schedule a job to validate the data every now and then, essentially, right? So this is kind of like a more, let's say, I would say, enterprise requirement, where like you're looking at our data our HOPSWORKS gets integrated with the rest of the data ecosystem that's available out there. Yeah. So what's new in HOPSWORKS 3.0 in terms of concept is the concept of feature views, right? So if you look back at it for pictures, the feature view, as I mentioned earlier, is the gateway for data scientists to actually use those features, right? To be able to actually use and create applications and train models and so on and so forth, right? So from a perspective, let me see, yeah, from an organizational perspective, right? What we actually seen, like before feature views, actually we had something called training data set, right? So training data set were kind of like everything all together, and while working with users and while working with different customers and so on and so forth, we noticed that people really didn't resonate well with the idea of training data sets. So we kind of went back to the kind of drawing board and say, okay, how do we make it easier for users to think about a collection of features used to train a specific model, right? So that's what we call feature views. And essentially it's a set of features with a bunch of more metadata that we're going to dig into now, that basically represents which features are needed for a specific model, right? So if I have a fraud prediction model, okay, these are my under features that I need to train my model and to serve my model and so on and so forth. But on the same feature group, on the same feature store, I might have a bunch of different models, other models that might need other set of features. And what feature views give you essentially as a user is a way to represent this different collection of features that can be used essentially, right? So how does that work? How does that look like in practice, and how does one use the feature view? Again, we stick again to Python. So the basic idea is that we do a bunch of metadata operation, and we instruct HOPSWORKS, say, here's the features I need for my model, and HOPSWORKS figures out how to actually get your features essentially, right? So at the high level, if you look through the code that is executed here, we start having, okay, we get the metadata information for different feature groups that I need, right? In this case, I need the the transaction feature group, and I need some other feature group that contains some aggregates information over a 4-hour window, right? So those are the features groups that are going to be needed. And specifically, right, if you look at line 6 to 9, here's the features I'm going to be using out of those feature groups, right? So from the transaction feature group, I'm going to select this set of features. I'm going to select the fraud label, category, amount, age of transaction, days until the can expire, and the location delta, right? So those are the features that I'm going to be using from the transaction feature group to train my model. And then from the Windows aggregation, I'm going to select all the features. I'm going to select all the features except the credit card number, right? That's a primary key. I don't want my primary key in my training data set because it's not a good idea to have primary keys when training a model. What does this do essentially, right? So this query, this like 4 lines of code are actually transpiled into a SQL query that gets executed by HOPSWORKS, right? And I kind of like showed it already, but this is kind of the query that gets executed. And this is quite complex, and actually it can get way more complex if you start adding multiple feature groups. Here we are just using 2 for simplicity. What happens essentially here is that the feature store provides you a way to enforce point-in-time correctness when you're joining features, right? What does that mean, right? What it means essentially is that if I have, and let me go back here a second. If I have the transaction feature group and the feature group being updated at different point in time, like for different frequencies, when I'm joining features from different feature groups, I want to make sure that I'm not leaking data from the future. And the future means if I have an event done at today, and let's say I have a transaction done today, at midday, I don't want to join with the windows for that credit card information from tomorrow or from 2 days in the future, essentially, right? So I want to make sure that the features are aligned time-wise, so that I'm not leaking knowledge of the future into the existing example that I might evaluating, right? And this is what actually the feature store takes care for you, right? And it builds this complex query, which is, if you were to write it in SQL, that's a pretty cumbersome query to write. It's pretty it's pretty error prone, to be honest, right? So it's easier to make mistake, and like, working with customers, so on, that's one of the sticky point that really people struggle with. Say, how do we actually write this query? And like, the answer is you don't, right? The answer is that you specify this in a way that it's pandas-like, essentially. So that's kind of the same API that you can use to merge data frame together in pandas, and that's essentially how you specify that in HOPSWORKS, right? And then HOPSWORKS takes care of executing that query, takes care of making sure that the data is point in time correct, and so on and so forth, right? So that's kind of the query, and then once we have the query, we can now then register the feature view. So we can say, okay, I'm gonna create a model to predict fraud, and I'm gonna call my feature view called transaction view. This is the query I'm gonna use. So line 13 essentially is basically say, okay, this is the set of features and the feature groups and the way I want them joined, and if I have filters, this is the way we can add filters, and so on and so forth. I'm gonna mark one feature, potentially a set of features, but like one feature as as a label. That's important when I'm going and serve my model. So when I'm going, for instance, batch prediction and or like even real-time prediction, what HOPSWORKS, and I'm going to show you the API in a second, what HOPSWORKS is going to provide you is a way of saying, okay, get me back a batch of data for this feature view, for this model, to be able to score that data. And I don't want the feature store to return my label, because that's exactly what I try to predict. So right, I'm going to mark this feature and say, okay, this is going to be a label. Giving back that label when I need to train the model, but when I'm actually scoring the model, just like obviously leave it out because you don't have that information, right? So that's one aspect. And finally, what we have is what we call transformation functions, right? That's what I was talking earlier before, that we split essentially what we consider like feature pipelines, like aggregation and dimensionality reductions and data validation, from transformation functions, right? So transformation functions are essentially a way for you to specify additional stuff like normalizations and one encoding, for instance, when you're creating a feature view. And the way you specify this, you can see a line like 15 and 18 to 19. Sorry, these are the set of features. Like, so I'm going to apply a label encoder transformation on the category. I'm going to apply min max scalar on both the amount and the days until the card expire, right? So these are for each feature, which transformation function I want to apply. And HOPSWORKS comes with like a default set of transformation functions. Label encoder is one, min max scalar is another one, and there is a bunch more. But you can also build your own, right? You can also create your own transformation function. You can also register them with HOPSWORKS and then use them in your feature views. One important aspect, and I think I have it as a rule here, right? So the feature view, the core concept here is essentially allows you to pull together a couple of different things. So it doesn't necessarily only pull together the feature groups and the features and transformation functions. One other thing that you can do is basically, and I'll show you, I'll go through one example in a second. One of the things you can do is basically say, okay, I'm going to generate train data from that feature view, right? So I want to train the model, I'm going to generate train data from that model. And when that happens, right, the normalization gets applied, and you're not going to be normalizing your training data. And the important aspect here is that the same normalization will have to be then applied when you actually go and score your model, when you score your data, both in batch or real time, right? So what HOPSWORKS does behind the scene, and you don't see that happening, you don't have to do anything from a user perspective, is essentially you basically essentially have to basically record the descriptive statistics, the descriptive statistic of your training data, and that information gets stored together with the feature view as additional metadata, and those statistics will then be used again transparently from a user perspective. They will get used again when you need to score the model or when you need to make real-time inference. So the feature views is basically like a collection of all these different components, the features that are needed, the transformation functions that need to be applied, as well as the statistics of the data that were used to apply those transformation functions, right? For obviously the transformation functions that acquire statistics. So you can do a stateless transformation function, and that's fine as well, right? So and again, from the feature view, you can ask, okay, give me back some data that I need to use for batch scoring, and the data that I need to be using for real-time predictions, essentially, right? So that's essentially one Python API to basically control the different life cycle of an MLOps pipeline, essentially, right? So everything kind of together, right? Yeah, so everything ties together. We do have a bunch of different things you can do in terms of like, and this is something that we already had before, allowing users to kind of create multiple projects and collaborate with different users. making sure we track lineage, making sure we track which feature group is which features are used in which feature view, and be able to kind of like have a complete view of what's going on in the feature store, as well as a way to kind of separate concerns between the different projects and different use cases. So you might have a lot of our customers kind of like have multiple separate use cases running on the same deployment. So you might have some data that's only valid for US customers, and you might have some data that's only valid for EU customers. And law says you can't mix them up, so you need to have them in separate projects. And that's kind of a way for you to kind of organize that kind of data and the kind of like workloads and workflows to be able to kind of separate the concerns and so on. Right? So you have a single platform, but you have different models working out of different data sets and so on. And then finally, this is a new thing that we launched with HOPSWORKS 3.0. So what we actually went back and said, how do we make the experience great for data scientists that want to get started with the feature store, and they want to get started with HOPSWORKS, right? So one of the components, one of the properties like a feature store is that there is a lot of like nice functionalities that require services and machines to run, obviously, and we don't want those details to be pushed to data scientists. So we don't want data scientists to actually be looking at being like a DevOps kind of people to make sure to run services and so on. We want data scientists to be focused on building models and building feature engineering pipelines and so on and so forth, right? So from our perspective, right, what we introduced is something called serverless HOPSWORKS. Essentially, it's a deployment of HOPSWORKS and I can show you in a second I can show you in a second how to get started with. It's a deployment of HOPSWORKS that allows you to basically just register, get an account, and start building some great pipelines, right? So I think I have a demo. Let me just jump on it a second. So this is HOPSWORKS. This is the serverless HOPSWORKS deployment, right? So this is the way you actually get to it. Essentially, if you go HOPSWORKS.ai, you click on login up here, and you can register an account. I'm already logged in, so it already redirects me to my environment. But yeah, that's essentially it. Like you fill in username and password, and you basically get an account up and running. The platform is free. It's available. We don't have any time restriction. We have some storage quota, but other than that, it's pretty flexible. You can build pipelines and run services and build cool stuff and write about it. We are more than happy to read the pipelines that you are going to be building on. To get started, we have prepared some tutorials that you can use. We have some of them down here. We have 2 like fraud tutorials that you can go through. We have an example of doing end-to-end wave prediction if you're like a surf enthusiast, like our CEO. So you can run it. You can run it on app as well. So you can build this prediction service. So here's all documentation, and there's a video, the presentation from Jim at PyData that goes through the details of this point. We also have an example of a churn use case. So there are different use cases that we have up and running, and there's more that we're building and so on, right? So the easiest way, to be honest, to get started is using Colab. We don't have any like big requirement. The only thing that you have to do is essentially running this pip install. So you can run the notebooks everywhere as long as you have a Python environment where you can install library and the environment can actually talk to HOPSWORKS. Other than that, there is no requirement. Obviously, the Colab environment is a quite controlled environment, so make sure that everything works out of the box. But yeah, you're free to run it everywhere. You don't have to run it on Colab. Okay, this is, I'm going to skip some of the steps because these are essentially what we were looking at before in the slides. So again, this example basically goes through some random CSV files that contain some transaction data. It does some feature engineering in pandas. Some computing the difference between like distance between this transaction and your previous transaction from the same credit card. So you're making sure that like you didn't travel halfway through the world in a couple of seconds before your next transaction. Elements of what are like, how many these are window aggregations, so how many transactions you have done in the past 4 hours, what was the average amount, what's the standard deviation of the transactions, and so on and so forth, right? So that's pretty standard. I mean, this is nothing HOPSWORKS related. This is something that like most of you probably have already seen. What really happens here is actually creating the feature group. So this is basically what we were looking at before. We basically specify the name, the version, and so on and so forth, and then we basically insert the data into the feature store, right? And what happens here is that there's going to be an ingestion job being kicked off behind the scene that's going to take your data and it's going to write it into the feature groups. So we can look at one of the feature groups that I have available up here. You can see like all the features that are available. You can if you look at what's the event time, if you have a primary key. I don't think I have a partition key. Yeah, no, I don't have a partition key. I have a bunch of information here. This is lineage. So where is your feature group being used? These are information about the data validation. So in the notebooks at some point I attached some data validation rules, and I'm going to run and I see, okay, there's a failure here. I have a credit card that is like expiring in more than 2 years, and so I have to do something about it. Here I can basically attach information, like if I can attach metadata that is custom metadata that I have, right? So for instance, I can say, okay, this data contains PII data, right? And the ultimate responsible for that is going to be my CEO, Jim Dowling. So I'm going to put that, I'm going to mark it, and then all this metadata gets indexed, and then you can search for it. You can search for it globally and in your project if you're on up. And this is what I was mentioning before. So if you have data validation enabled, then you can also set up alerting and basically say, can I trigger an alert? Can you send me an email if data validation fails, and so I can get notified if a pipeline fails, right? So we do have a bunch of other things that we can do, right? For instance, we can compute statistics. So from a data science perspective, if you are looking for using, I don't know, the feature age of transaction, you can see a bunch of information. So you can see the minimum user is like 17 point something years old, and the maximum is something almost 101 years old, making transactions. And then you can see the distribution of values and so on and so forth. You can do that for a bunch of different features. For some features, obviously, if we have too many different values, we don't compute, and it's not an integer. We don't compute distribution. But for most of them, as you can see the distribution and so on. What you can also see, and this is also interesting, you can actually, as you start having more and more features, what you can also do is basically looking at the correlation between the features. So there might be a feature, and not in this case, where it's highly correlated with another one. So it doesn't make sense for you to compute both of them, right? As they provide the same signal. You might want to drop them. You might want to like stop maintaining that feature. And you can do the same. You can actually do the same for feature view as well. And I'll show you in a second. So yeah, that's kind of an overview. We have a bunch of more functionality that we can go through, but I don't think I have full time yet. That we can go through in terms of like more kind of metadata that you have available. Anyway, let me go back to the notebook. So we added the feature views. Sorry, we created the feature group. And we also did the query here. So this is the same query that we were looking at before, with the point-in-time correctness taken care by the platform. And then we create the transformation functions and the feature view, right? So again, here what happens is the same. We go back to, let me zoom in a second. We go back to HOPSWORKS. We can track the feature views, and you can see the different versions, from which features are involved, which one is the target that you're trying to predict in this case, where are they coming from, which transformation function you have applied on, which types they are, and a bunch of additional metadata that you can attach. And you can also compute statistics for the feature view as well. So again, if you have cases where you have similar features, you might not want to keep, you might want to drop them from the feature view to speed up your model, the development and training and so on. And then you keep going. Like here, we create a train data set. So essentially, we basically say, okay, get me the data between these two timestamps. Since we are dealing with time-based data, create a train data set. We basically we can also either create a train data set on like one time, but we can also get it on the fly, where you can also split it, right? So you can basically get back your training and test data, and this is all split and managed by HOPSWORKS. And finally, yeah, you can go through the model, you can train your model, and finally you can also deploy the model on the platform. So HOPSWORKS serverless comes with integration with Kserve and allows you to basically deploy models, and you get back basically a live REST endpoint that you can make prediction to. Again, you can use the API to do that. You can also make the prediction through the REST API essentially, and you can build like nice UI. If you go to this notebook, it also brings in radio, and you can basically build up the like a nice UI to kind of look at it. Again, the platform is free. There's no time limit. Come here, just build cool stuff. There's a bunch of video quota. If you're out of quota, let us know. And we see what we can do about it. And yeah, I look forward to kind of see you building things. I think I have a couple of more minutes to take some of the questions that are there. Let me go back to.
I can jump in at this time, Fabio. We have one queue from anonymous attendee. Does HOPSWORKS allow you to manage the add or remove individual features inside a feature group? So if you have a feature group already, can you add a feature to it?
Yeah, you can append features. So we have an entire, let's say we have an entire like concept of versioning that you can read up a little bit more in our documentation. Essentially, we want to the main concern is to prevent you from breaking existing API, right? Existing pipeline, right? So from our perspective, we divide this type of modification in terms of like breaking changes and not breaking changes. If you have adding additional features that's a non-breaking change, so you can append it to an existing feature group. So you basically say, okay, go back and add this new feature to this feature group. If you want to remove a feature, then you need to create a new version. And what that means essentially is that all your feature views using that specific feature group will have to be updated, and you will have to make sure that like the feature view either doesn't use the feature that you dropped, or gets retrained without that feature view, that feature essentially. So again, you can go in the documentation, and we have like different level of versioning, and we have like a good explanation on the different versions and so on. But again, adding features is possible on existing feature groups. Removing needs to create a new version.
Yeah, we had actually, there was a discussion on Twitter, I think, by a bunch of people this week about testing and when you should do testing of features, and if you add or remove a feature from a feature group, should you have to retest the entire feature group? And I was of the opinion that individual columns or features should be tested independently. And then if you're adding or removing features, it might mean you need to add new tests for the feature logic for the new feature you're adding. but it shouldn't break the existing tests. I don't know what because some people test on full data frames. So they're writing testing pipelines that will read some sample data into a data frame, compute something. Maybe they're using the features to maybe to train a model or to make predictions. And then they check to see if the predictions are good. And then, of course, if you add a column or remove a column, that whole thing breaks. What's your take on that?
I mean, I think there's a two-level things you have to consider, right? So there's like individual logic that you test, and I agree. Like I think it has to be independent. So that if you add additional feature, then obviously you wanna only consider that test, right? I mean, obviously you can run the full test suite, but you shouldn't need to touch the existing features. There's a general, like I think if you do more comprehensive tests, I think those more comprehensive tests are better suited using library like Great Expectation, where you're not testing the logic per se, but you're mostly testing. If you're testing the output, you might be interested in testing your assumption to the data, right? So making sure that you have good assumption, and those assumptions are valid in your data.
Actually, one thing about when you write Great Expectations, you can actually write tests for those as well to make sure they work. So you can have a small amount of test data, and your PyTest unit test can be used to test to make sure the Great Expectations rules that you wrote actually work as expected. That they learn. Please, if anyone has questions, please ask them in the chat. I see another one has popped up here. So this one is from Jesus Jimenez. Thank you. And how do you manage the test, dev, prod lifecycle of the features? So do you have are there two or more HOPSWORKS servers for dev and for prod?
Yeah, so I think there are two aspects here to answer. Okay, the first one I would say, the minimum set is actually having different projects. So making sure that you have a production project which is probably more locked down, and maybe you might have like tools like a CI/CD pipeline actually only writing features there, and then you might have a more open development project where you give the freedom to the scientists to actually try it out, different things and so on and so forth. So making sure that people in the development projects, they can potentially break things, but those things actually don't break production. So that's a kind of the minimum level of separation that we have, and that's achieved to what we have in HOPSWORKS, the HOPSWORKS projects. What you can do is what you can also do if you are concerned about resource utilization, then you can also split the production cluster on one side, and then the HOPSWORKS cluster on another, like a test and development cluster on another side. So there's different levels, and if you are on the cloud, that's more easy. You can just spin up a new cluster. If you're on prem, it's a little bit more challenging, but I would say having a separate cluster between dev and prod is probably a good idea to avoid, to make sure that resources are isolated and so on and so forth, right? So that's the two level of test prod and how we manage the lifecycle. And the way you move features between the two is that you're not necessarily moving your feature data, you're moving your feature definition, right? So if you are, like most of the cases that we have seen in HOPSWORKS, is that the test platform runs usually on test data, and then you define those features there, and then you move that feature definition into the production project. You commit it to a Git repository, and then you're gonna have a CI/CD pipeline that runs them on a production project, and then the production project is gonna recreate the same feature, but this time on the actual production data, and it's gonna run that feature pipeline there.
So basically, you run the same code but pointed at a different feature store. Yeah. Okay, more questions. So anonymous attendee, how do multi-users on project get managed? Some sort of CI/CD. I think there's a confusion between managing users and CI/CD here, but
yeah, I think so in HOPSWORKS you can collaborate within projects. So a project is a collection of features, feature groups, feature views, but also users, right? So you have different users on a platform, and then you can also have different roles within the project. So some users can only, what we call data scientists, or read data, and some users in HOPSWORKS are called data owners. They can also own data and create data and delete data and so on and so forth. So there's that level. And then within a cluster, users can have access to different subset of projects. So some users can have access to all the projects. Some users can only have access to, I don't know, the fraud team projects and so on and so forth. So all that kind of thing is managed through HOPSWORKS. And then
it's very self-service as well.
Yeah. And then CI/CD, I think, like from CI/CD, then you can have service accounts, and then you might have like a Jenkins Airflow or GitHub Actions account that can basically just do things as a service account essentially.
We have Akash Shah has 2 questions. So what database do you use? And then secondly, do you store the data of the query or what the feature views returns? So I guess this relates to what, when you run a feature view query to create training data, where do we store all that metadata, or do you store all that metadata?
So like for the first question, the database is actually a dual database system, right? From one side, we have RunDB for which is like a key value database for doing the real-time part, right? So all the online feature store and low latency query and inference vector for real-time predictions, those are served out of RunDB. And if you're deploying on HOPSWORKS, if you're using serverless HOPSWORKS, you don't really see it. If you're deploying it within your own VPC, it's deployed and managed automatically by the platform. And instead, the what we call offline, it's more like a batch for training and batch inference. Those are stored on OpsFS and S3. So those are the technologies that we use for storing data for the offline feature store. And then we used Apache UD as a file format that allows us to do cool stuff like data versioning, going back in time, and so on and so forth, right? So that kind of technology stack, depending a little bit on what you're doing, gets used. And the question is like, what does the feature view actually store and returns? Like the feature view doesn't store any data per se. The feature view is just a pointer. Like you can think it as a kind of a store procedure, like to the feature store, right? So it doesn't store any data itself. It just points to the underlying feature group that is basically composed the feature view, right? So when you are retrieving a feature vector for online inference, the feature view will go to the online feature store and you're going to get the data back from the online feature store. If you are looking at generated training data or like doing a batch inference, in that case, it's going to go to your offline feature store and it's going to retrieve like potentially like a larger quantity of data and return it back to you essentially. So the feature view just store the metadata and knows how to retrieve the feature depending on what the user requested. The format that is returned it's returned as a pandas data frame, right? So and if you are doing inference vector, it's just going to be returned as a Python array essentially, right? So but if you're training models and so on, those are pandas data frames.
Hey, okay. I think we're out of time. We're just shy of the top of the hour. Thank you everyone for listening. And thank you, Fabio, very much for presenting a fascinating talk. Just a reminder, everyone, there is the conference, the Feature Store Summit on October the 11th. Be sure to register. It's at featurestoresummit.org. Lots of great speakers coming, and hope to see you all again at the next event. Thank you very much and have a great rest of your day, wherever you are.